You ever see something get hot or cold, like all by itself? No plugs, no batteries, nothing. It kind of seems like magic, right? Well, today, we're going to pull back the curtain and show you the incredible science that makes it all happen.
I mean, really think about it. You take a hand warmer, you snap that little metal disc inside, and poof, it gets toasty warm. Or, one of those instant cold packs for a sports injury. You just squeeze it, and it gets ice cold. How in the world does that work? That's the big question, and that's exactly what we're going to get into.
So what's the big secret here? Well, it's not magic at all. It's chemistry, and it all boils down to two really important, kind of opposite ideas that explain how energy, usually heat, moves around during a chemical reaction.
And here they are. The two big words of the day are exothermic and endothermic. Now, they might sound complicated, but I promise the idea is super simple. Exothermic reactions let heat exit, they give it out. Endothermic reactions pull heat in. So one makes things feel hot, and the other makes things feel cold. Let's take a closer look.
First up, let's talk about the warm and cozy side of chemistry. These are the exothermic reactions. These guys are the givers. They're all about releasing energy.
So here's the deal. When an exothermic reaction happens, the chemicals involved release all this energy they had stored up. And that energy has to go somewhere, right? So it flows out as heat into everything around it. The air, your hands, you name it. And that's what makes everything feel warmer. And what's so cool is this stuff is happening everywhere. That amazing feeling of a roaring bonfire when you're out camping? That's a classic exothermic reaction called combustion. Those clever little hand warmers, or even those self-heating cans of hot chocolate, they're all using this exact same principle to create heat right when you need it.
All right, let's flip the coin and check out the other side. If exothermic reactions are all about giving heat away, what do you think endothermic reactions do? Yep, you guessed it. They do the complete opposite.
That's right, they take heat in. An endothermic reaction is basically an energy hog. It actually needs energy just to happen, so it starts sucking in heat from its surroundings. It's like a tiny heat vacuum, pulling warmth out of whatever it's touching, and that's why everything around it feels colder.
And you see these in real life all the time, too. That instant cold pack? Perfect example. Squeezing it kicks off an endothermic reaction that literally pulls the heat away from your sprained ankle. A snowman melting on a sunny day has to absorb heat from the sun to turn from ice to water. Even plants get in on this. Photosynthesis is an endothermic process that uses sunlight to create food.
Okay, so we've got the what down. Things get hot or they get cold. But the bigger question is, why? Well, it all has to do with the energy the chemicals have stored inside them both before and after a reaction. And to get that, we just need to know two quick terms.
First up, we have reactants. Now, don't let the word scare you. It's just the fancy science name for the ingredients, the stuff you mix together at the beginning of a reaction.
And once those ingredients have done their thing, you get your products. This is just the new stuff you end up with when it's all over. So your reactants become your products. Simple as that. Okay, now this is the real key. In an exothermic reaction, like our bonfire, the products, so the ash and the smoke, actually have less stored energy than the reactants did, which was the wood and the air. So where did that extra energy go? It was released as all that awesome heat and light.
And for endothermic reactions, you guessed it, it's the exact opposite. The products actually have more energy than the reactants started with. So to get that extra energy, the reaction has to pull it in from the outside world, from its surroundings, and that's what makes everything feel cold. Now, there's just one last piece to this whole puzzle. If a bonfire releases so much energy, why doesn't a pile of wood just burst into flames all by itself? Well, it turns out it needs a little push to get started. That push is called activation energy. The best way to think about it is like pushing a big ball over a small hill. You've got to put in some effort to get it to the very top. That's the activation energy. But once it's over that hump, it can roll all the way down the other side. Every single reaction needs to get over its own little energy hump to get going.
So for our bonfire, the activation energy is the heat you get from striking a match. That tiny bit of initial energy is all it takes to get the reaction over that hump, and then whoosh, the massive release of heat begins, and it keeps itself going.
Okay, you've learned a lot. You know about reactions that give heat out and ones that take it in. So, you ready for a quick challenge to see if you've got this down? Have a look at this table. A scientist did 4 experiments and wrote down the temperature at the beginning and at the end. Your mission is to figure out which of these reactions are exothermic. Now remember,
Exothermic means it gives out heat. So what do you think should happen to the temperature?
So how did you do? The answer is reactions 1, 3, and 4. They're all exothermic. We know because in each one, the final temperature went up. Heat was released. And that makes reaction 2, where the temperature dropped, our one and only endothermic reaction. Great job!
Before we finish up, I want to leave you with this fantastic memory trick. It's a super simple way to keep these two straight. Just remember, in exothermic reactions, heat exits. And in endothermic reactions, heat enters. X for exit, En for enter. It's a lifesaver, trust me.
So, as we wrap things up, let's bring it all back home. This isn't just some weird science thing. The world around us is buzzing with these invisible energy transfers happening all the time.
And now you know the secret of the self-heating can and the instant cold pack. It was never magic. It was just chemistry. This constant dance of energy being released or absorbed as chemicals rearrange themselves into something totally new.
So I'll leave you with a final thought. You kind of have a new scientific superpower now. You can see the invisible flow of heat. So as you go about your day, look around. When you see something get hot or something get cold, ask yourself, is heat exiting or is it entering? What other examples can you find out in the wild? You might be surprised by how many you spot now that you know the secret.